Be greeted, people. I hope you are doing good today. This is Elton from Maths and Science series. We are continuing with our lesson on redox reaction or reduction oxidation reactions. Remember, we did the first part of showing you how to determine the oxidation number. So today we'll be doing the second part where we'll be talking or discussing about oxidizing agents and reducing agent, and on how you should find the oxidizing agent or the reducing agent. So be greeted. This is Altin. Please, as you are continuing listening or learning here in our channel, please make sure that you subscribe as you are watching this video. Please do it now so that you won't forget. Subscribe, like, share and comment as a way of thanking us, guys. So today we'll be discussing oxidizing agent and the reducing agent. But before you can watch this video, make sure that you watch the first part so that you can understand what we were doing here. The first part was when we were doing the oxidation number. So for you to know how to find the oxidizing agent and the reducing agent, it's very important for you to know how to find the oxidation number. So make sure that you watch that video if you haven't watched it yet. So we'll be discussing about these two agents. So it is very important for you to know how to define them. So when you define oxidizing agent, you define it as follows, or as you can see it on your screen. Oxidizing agent, it is the substance causing the oxidation of the other substance and is itself reduced. Okay, what does that mean? Oxidizing agent, we're saying that it is the substance causing the oxidation. What does the term oxidation mean? It means the loss of electrons. So we are simply talking about the substance that causes the loss of electrons of the other substance and is itself reduced. Okay, you will see the difference. Let me talk about the reducing agent. We're saying that a reducing agent, it is the substance causing the reduction of the other substance and is itself oxidized. So we have the term reduction when we are defining reducing agent. So the term reduction means the gain of electrons, right? Now the substance causing the gaining of electrons of the other substance and is itself reduced. If you can, you are looking on your screen there, you can see that oxidizing agent, at the end of that definition we have the word or the term reduced, right? And in reducing agent, at the end of the definition we have the term oxidized. So don't make this mistake saying that, let me define the reducing agent. Some other learners are making this mistake. They're saying that the substance causing the reduction of the other substance and is itself reduced, since they can see that they are defining what reducing agent. But at the end of the definition of reducing agent, we have the word oxidized, not reduced. Do not make that mistake. So when we define it, we say that the substance causing the reduction of the other substance and is itself oxidized. Don't put reduced, because when you talk about reduced, it is when we are talking about what? Oxidizing agent. So it is very important that you put in mind these two words, reduced and oxidized. We're going to talk about them a lot, since we are going to talk about or we're going to show you on how to determine the agents or reducing agent as well as the oxidizing agent. So now I'm going to just make a quick recap on how to find the oxidation number. I'll just make two examples, and after that we continue. Okay guys, so this is how you should find the oxidation number. So it is very important, before we can discuss about the agents, make sure that you know how to find the oxidation number, because oxidation number is the first step for you to find or to determine the agent. Now find the oxidation number of MnO4 minus. We have MnO4 minus, but we have to find the oxidation number of manganese, right? Now, this is what we are supposed to do. We say Mn plus How many oxygen atoms do we have here? We have 4 oxygen atoms, and I write 4 oxygen atoms. So it means that I took this again, I took the subscript, then I made it to become what? The coefficient. Then I equate it to the net charge. The net charge, it is -1. Since we have a negative here as an exponent of the whole compound. But if I had something like maybe 2 minus, I will equate it, I will make it to be on that right hand side of the equal sign, since it will be the net charge. Now, since we know that whenever oxygen atom it is bonded with other elements, it means that its oxidation number, it is always -2. Then you simplify, you have Mn minus 8 equal to -1. Then Mn equals +7. So this is what the oxidation number of Mn. So it is very important that you watch that first video or the first lesson of the first part where we were determining the oxidation number of the substances. Now let's do the second one, then we continue with discussing about the agents. Now we know that I gave you the rules on that first part, on that video of determining the oxidation number, that whenever a hydrogen atom it is bonded with other other substances or other elements, it means that its oxidation number, it will be +1. Since we know that in the first group, or in group 1, the oxidation number, it is +1. Now we have, how many hydrogen atoms do we have here? We have 2. So I'll say 2H plus sulfur equal, what is the net charge? Since we have nothing, we put 0. But if it was negative or 2 minus or 3 minus, we will put -2 here. I hope you are following. So if you are not, make sure that you watch that first video where we were determining the oxidation number. So I will say 2, I substitute 1 here, since we know that the oxidation number of hydrogen, it is +1 when it is bonded to other elements, plus sulfur atom equals 0. Then we say S equal to, we transpose the 2 to the right, it becomes 2 minus or -2. So that this is how we are finding the oxidation number of the substances. So it is very important, because even when we are going to find the agents, it is very important that you know how to do this thing. So make sure that you know how to do it, because you cannot find the agents if you don't know how to find the oxidation numbers. Okay, let us start our second part of the lesson, which is how to find the the reducing and oxidizing agents. So I'll find both of them just to show you on how to find them. All right, now the first thing I told you that the first thing that you're required to do before you can find the oxidation, the agents, you have to find the oxidation number first. So you can see that here we don't have the oxidation numbers, so we have to write the oxidation numbers before we can find the agents. All right, I told you on that video, on that lesson, where we're showing you how to determine the oxidation numbers, that whenever you have a monoatomic atom, it means that its, or monoatomic element, its oxidation number, it is always 0. So even here we have 0, but we know that when hydrogen atom, it is bonded with other elements or another element, it means that its oxidation number, it will be +1. And we know that oxidation number of oxygen atom, when oxygen atom, it is bonded with another element or other element, it means that its oxidation number will be -2. But now we can't put -2. Why? Because oxidation number, because the oxygen atom here, it is not yet bonded to other elements, but it is just a it's a diatomic element, or just hydrogen gas and oxygen gas. So I've written the oxidation numbers of these elements. That's the first part. You check if that equation of your that reaction of yours have what oxidation numbers or not. So if it doesn't have the oxidation numbers, or the oxidation numbers are not written, you have to write them down before you can find the agents. But now we can see on the product side that the H and the oxygen atom, they are bonded. They formed what? A compound known as H2O or water. And we know that whenever oxygen atom it is bonded with another element, it means that its oxidation number, it will be -2, and the oxidation number of hydrogen, it will always be +1. I hope you understand that. So here we have 2H plus how many oxygen atoms do we have? We have 1 equal to 0, the net charge. I hope you understand this if you watched that first video where we're determining the oxidation number. So we know that since hydrogen it is bonded with another element, it means that its oxidation number, it will be +1. Now we find the oxidation number of oxygen atom, which is 0 minus 2. We transpose that 2 to that right hand side. Remember, 2 times 1 will give us 2. Now we shift it to the right hand side. It will be -2. Therefore, the oxidation number of oxygen atom, it is -2, or it is 2 minus. Then I have to write them. So I've written the oxidation numbers of these elements in the compound H2O or water. So what is the next step since I found the oxidation numbers of these elements or substances? Now we have those agents. Remember, we have what? The oxidizing agent and as well as the reducing agent. Okay, so it is very important for you to know how to find, or for you to know how to define these two definitions or two terms. All right, now let's group them together. The H2O hydrogen atom with the hydrogen atom, oxygen atoms with the oxygen atoms. All right, now you can see from the electrons of the H atom or hydrogen atom in the reactant with that hydrogen atom in the product side. When you check, or as you can see, the electrons from 0 to 1, the electrons increased, right? From 0 to 1. I don't know if you understand that. So what does that mean? It means that the oxidation number of hydrogen increased from 0 to +1. I don't know if you understand that. So we have this thing. We have that thing that says an increase in oxidation number is oxidized. Then a decrease in oxidation number is reduced. So an increase in oxidation number is oxidized. Then a decrease in oxidation number is reduced. Let me just write it down. So an increase in oxidation number is oxidized. Then a decrease in oxidation number is reduced. So since we can see that here the oxidation number increased from 0 to 1, it means that we are here. Okay, so we write oxidized here. Right? Why? Because an increase in oxidation number is oxidized. since the oxidation number increased from 0 to positive 1, right? Now, let's check this one, then I will show you how to conclude this. Now, we have 0 here, then here we have 2 minus or negative 2. So, did the oxidation number increase from 0 to negative 2 or it decreased? Remember, we want to check what number did they subtract from 0 to get negative 2. They subtracted negative 2. So, by the term subtracted, it means that it has decreased. So a decrease in oxidation number is reduced. Then I write reduced here. Make sure that you understand this. It is very important for you to know how to do this. Now, we said that an increase in oxidation number is oxidized, right? I wrote oxidize here, and on these elements where there is an increase in oxidation number, then I've written reduced here since there's a decrease in what? In oxidation number. Now, we go back to our agents. We said that a reducing agent, it is an agent causing the reducing agent, it is the agent causing the reduction of the other substance and is itself oxidized. Then when we define the oxidizing agent, we said that oxidizing agent, it is the substance causing the oxidation of the other substance and is itself reduced. So it means that since this one, it has what? Oxidized, or since this one has reduced. When we compare our two agents, that oxidizing agent, the last part of its definition, it is reduced, right? Then the last part of the reducing agent's definition, the last part of the definition, it is oxidized. It means that the ones that are oxidized, we say that they are what? They are reducing agent. So it means that H, it is what? The reducing agent. Then the oxygen atom, it is what? The oxidizing agent. I don't know if you remember those definitions I gave you, that the oxidizing agent, it is a substance causing the oxidation of the other substance and is itself reduced. So whenever we have an increase in oxidation number, it means that those elements or that element, it is oxidized. So since it is oxidized, it means that it is what? The reducing agent. So don't see oxidized, then you say it is the oxidizing agent. When you have an increase in oxidation number of the elements, it means that those or that element, it is called the reducing agent. And when you see the reduced elements or the reduced element in that reaction that will be given, since here we said that the oxygen atom, it is reduced. Why? Because there's a decrease in oxidation number. Then we say it is reduced. It means that you don't have to say that it is the reducing agent, but it is the opposite. What is the opposite agent? It is the oxidizing agent. I don't know if you understand this. So it is very important. Don't see oxidized here, then you say it is what? The oxidizing agent. As you see the reduced agent, don't say it is the reducing agent. But when you have oxidized, or when you have an increase in oxidation number, it means the agent that is responsible for whatever that is happening there, it is the reducing agent. But when you see a decrease in oxidation number, then a decrease in oxidation number, we say that it is reduced, right? Then since we know that our agents, this one, when you define it, it ends with the term oxidized. Then this one, when you define it, it ends with the term reduced. So those last terms, or those the end terms of these definitions as I gave you on the first part when I was defining this agent. Those last part or those last terms, they're telling us about the agents which we must choose when we are given what? The reaction to find the agents. I don't know if you understand it, but I will do the second example so that we can understand what is it that I was doing here. Okay, this is our second example because there was some that I didn't touch on that previous example, on the first example that I just did. So I'll do it here. Let's hope we will follow. All right. Now we are given this reaction as zinc plus silver ion plus zinc ion plus silver. Now these are reactants, then those ones are products, since you know that, right? Now this is a monoatomic atom or element. So since it is not bonded with any other elements, so it means that its oxidation number, it is always B0, right? But on those other ones we are given, except on the zinc on the side of the reactants and silver on that side of the product, and it is also 0 here. Remember, it is very important for you to know how to find the oxidation number before you can do it, before you can find the agents. So these or these things that you can see here, let me say we're in math, we'll say that they are what? They are exponents. So they are called oxidation numbers. Now let's match them. Zinc goes with zinc, silver goes with silver, or Ag with Ag. Now, you just write this thing here. Make sure that you write it all the time so that you can remember it. An increase in oxidation number is oxidized. Just write it before you can find the the oxidizing agents or the reducing agent. A decrease, because it will help you to remember easily. A decrease in oxidation number is reduced. And remember, when it is reduced, it is what? It is telling us about the reducing agent. Make sure that you write this. Then when it is reduced, it tells us about the oxidizing agent. It is simply the opposite. I don't know if you can see that. Yeah, so make sure that you write these things before you can find the agent. From 0 to positive 2, we have what? An increase in oxidation number. So we write what here? We write oxidized. Why? Because there is an increase in oxidation number. I hope you are now following. I can see that. Okay, now here we have a positive 1. So from positive 1 to 0, do we have an increase or a decrease? From 1 to 0, they subtracted 1 to get 0. So we have a decrease in oxidation number. Then we write reduced here. I don't know if you can see that. Now you have to conclude. Remember the agents. The reducing agent, when you define it, at the end it has the term oxidized. So it means that zinc here, it is what? The reducing agent. I can feel it that you are getting the gist of what I'm doing here. Now, these ones, they are reduced. So it means that, or you just remind yourself of the definitions of the agent. So it is very important that you know how to define them, because you can't know which is the reducing agent and which is the oxidizing agent without knowing first how to define them. Now, the end part of that definition of the oxidizing agent, it ends with the term or with reduced. So it means that this is what the oxidizing agent, right? So that's very, very, very important. Let me just remove this because there's something interesting in question papers that they like to ask. All right, we know that zinc or Zn2 plus, it's what it is, the reducing agent, right? And we know that Ag plus or Ag is what? The oxidizing agent. This is what we know, this is what we have discovered. Now, they can ask you, why are you saying that these are reducing agents? Then they ask it like this: explain in terms of oxidation number, why did you say that the ones which you saw or the ones which you chose to be a reducing agent, why are you saying that they are oxidized or they are reducing agents? So the most important thing, or the first thing for you to do, is that you have to explain it in terms of what? Of oxidation numbers. You just tell them what happened, or why are you saying that they are oxidized, or why you are saying that they are reduced. So let me explain this one first. Why are we saying this? It is the reducing agent, or why are we saying it undergoes oxidation? It is because the oxidation number, or what, the electrons, they increased from 0 to positive 2, then you get 2 marks. So they can ask you, why are you saying that the ones that you chose in question 1, if it was question 1 where you were asked to find the reducing agent or the oxidizing agent, they ask you, why are you saying that whatever in question 1 that you chose, why do you say that it undergoes oxidation? Then they say, explain in terms of oxidation number. Since they are talking about oxidation, why are we saying that it undergoes oxidation? We'll say because the electrons, they increased from 0 to 2. You just write that, then you get 2 marks. Or you just say because there was an increase in oxidation number from 0 to positive 2, if they talked about oxidation. But when they say, why are you saying that in question so and so, those elements, they undergo reduction? You say because there's what? There is a decrease in oxidation number, or you simply write that the electrons, they decrease from positive 1 to 0. Then you get your 2 marks. So that's very important. That's very important. Make sure that if you didn't hear what I was saying, just start afresh the video so that you can understand what I was simply saying. I hope we understand each other here. Let's do the second one. I mean the third example. I think I'll do 5 of them. Then after that, I'll give you yours. Then if you got it correct, you'll do it. You'll just put on the comment platform saying thanks. I'll understand that you got that sum, or you get that agent, if we just, as we are talking about agents here. Okay, this is our third example. Luckily, I've written all the numbers of, or we are given the oxidation numbers of all the elements we are having, right? Now, since that we know that that becomes the first step of writing the oxidation numbers. So they gave us. Now let's just match them. Aluminium with aluminium, copper with copper. Now you write that here or before or wherever, where you will see that an increase in oxidation number is oxidized and a decrease in oxidation number is reduced. Now from 0 to positive 3, did it increase or decrease? So it has increased. So an increase in oxidation number is oxidized. So since they are oxidized here, the most important thing for you to know it is that they are called what? The reducing agent. So we say that they are reducing agent, right? Now, these ones from 2 to 0, they decrease. They subtracted 2 from these two to get that 0. So we say that a decrease in oxidation number is reduced. Reduced. Then we know that reduced, it is when we are talking about what? The oxidizing agent. So this is how we are doing it. This is how we are doing it. I hope we are all following. Remember, an increase in oxidation number is oxidized. Then a decrease in oxidation number is reduced. Why are we saying that these they decrease? It is because from 2 to 0 they decreased, right? They subtracted 2 to get that 0 there. I don't know if you understand that. Then we say that they are reduced. So if they can ask you why is Al undergoing oxidation, or why are you saying that it undergoes oxidation, it's because the electrons, they increased from 0 to +3, then you get that 2 marks. Why are you saying that copper undergoes reduction? It's because the electrons, they decrease from 2 to 0, then you get your 2 marks. So it's very important that you know that. Let me just look for a more complex one. Then we see how we are supposed to find the agents. But the most important thing is that the first thing for you to know, you find the oxidation numbers of all of those elements. Then you do what? You match them. Then you conclude. You see? So it's not like they're going to ask you in an exam, they're going to ask you both of the agents. They can ask you one agent. So this is how you are supposed to find it, or this is how you're supposed to determine it. So let me just write a complex one. Okay, let's try this one. All right. Now we are to determine both the agents, right? But in an exam, they can ask you one agent. But this is still the process of finding it. It's just here we're finding both of them, but they can ask you to find a reducing or the oxidizing agent. So the first thing which we are required to do, since you are getting the gist of it, we have to find the oxidation numbers of the substances or of the elements. We have zinc. Okay, we are given, we are not given, we are given, we are given, we are given. So it means that we have to find the oxidation number of bromine or Br. Since we can't find the oxidation number, since we can't find the agents without having the oxidation number of all the substances we are having or all the elements we are having in our reaction. So we have this one, we have this one, we have that one. So I have to find Br. So we just do it aside. Br plus how many oxygen atoms do we have? We have 3. So we take this coefficient, we take this subscript and make it what? A coefficient equal to, what is the net charge? The net charge becomes -1, right? You can pause this video, then you do what? You do it on yourself, or you do it on your own. Then after that, you continue the video to see if you will get what I will get, or you will have your answer correct or incorrect. So that will be just training yourself. So Br, we know that whenever oxygen atom bonds or it is combined with other elements, it means that it will have an oxidation number of -2, right? Okay, now Br -6 equal to -1, then you say Br equal to -1 plus 6, we have +5. It means that the oxidation number of bromine here, it is 5 plus or plus 5. Okay, let's just erase this to continue. Okay, let me just write it with a black color. All right, now let's match them. Zinc goes with zinc, bromine goes with bromine. Okay, you write that thing that an increase in oxidation number is oxidized, a decrease in oxidation number is reduced. So from 0 to positive 2, they added 2 here to get 2 there. So there's what? An increase in oxidation number. So we say that an increase in oxidation number is oxidized. We write oxidized. These ones, they are oxidized, or rather, let me just write it here, oxidized. Then from 5 to negative 1, did our oxidation number increased or decreased? They decreased, right? Because they say 5 minus 6, they got negative 1. We will get there where we will explain how many electrons are gained or how many electrons are lost when we are going to do the half reactions. That will be our part 3. But before you can understand them, you have to understand these ones because they work. Part 1, part 2, for you to understand part 2, which is this. This is part 2, you have to understand part 1. And for you to understand part 3, you have to understand this part 2. Okay. Now, from 5 to negative 1, they decreased, right? So we say that a decrease in oxidation number is reduced. Do not forget that. So you remind yourself of the agent that an oxidizing agent, it is what? It is a substance causing the reduction of the other substance and is itself oxidized when you talk about the reducing agent. So a reducing agent in definition is a substance causing the I'm saying okay, the oxidation the oxidizing agent. It is the agent causing the oxidation of the other substance and is itself reduced. So it means that these ones, we say that those ones, or the term or the way that the end part of the oxidizing agent, it ends with the term reduced. So these ones are, we say these are oxidizing agent, and these ones, since they are oxidized, when we define the reducing agent, we say that it is a substance causing the reduction of the other substance and is itself oxidized. So this is what the reducing agent. Don't say since they are oxidized, you say it is oxidizing agent. When they are reduced, you say it is the reducing agent. You just write the opposite. When it is oxidized, it is a reducing agent. When it is reduced, it is the oxidizing agent. So the reason that zinc undergoes oxidation, it is because the electrons, they increased from 0 to positive 2. Then you get your 2 marks. They asked that question, that why is zinc, if you discover that zinc undergoes oxidation, why is zinc undergoing oxidation? Just explain, or just write that, because they will say, explain in terms of oxidation number, why is zinc undergoing oxidation. They ask those types of questions. You just have to say that because the oxidation number, or because the electrons, they increased from 0 to positive 2. Now, why is it undergoing reduction? It is because the electrons, they increased from 5 to negative 1. So that's very important. That's very important. This was our last part of finding the agents. I hope you guys understood everything I was doing with you. So I'll just write the last one here, but I won't find the agents. I will ask you to find it. then to prove if you understood what we were doing. Then after that, try to attempt past question papers where they're asking about the agents and the oxidizing, and the oxidation numbers, to see if you understood what we were doing. So before you can watch this one, or before you can understand what we're doing here, you have to make sure that you understand the first part where we were finding the oxidation numbers. So this was the second part. The first part was where we were finding the oxidation numbers. The second part, how to find the reducing and the oxidizing agents. The third one, it will be the one where we will be writing the half reactions. So it is very important that you watch this. So please subscribe, like, share, and comment as a way of thanking us for explaining this thing or these things in a more simpler way. So good luck, guys, as you are still continuing term 4. You'll be doing this, so make sure that you are promoting it so that other people can get the help that you are getting. So do not forget to press on the notification bell so that you can be notified when we upload new videos. Thank you. Okay, guys, so try and do this one to prove if you got it, or to prove if you understood what we were doing. Then leave your answer on the comment platform. So since this is the first example that I'm giving you to do on your own, so just write, okay, let me just be specific. Find the reducing agent. Then on the comment platform, you just write that substance or that element that you saw as what, or as you got as the reducing agent. So find the reducing agent, then you write your answer on the comment platform, that if Cl it is the reducing agent, you write it down. You write it on the comment platform as a way of so that I can see that what I'm doing is correct, or you're understanding what I'm doing. So please do not forget to write your answer on the comment platform. Find the reducing agent.